Hi, today we are going to see the topic linear vector space. What is linear vector space? It is defined as a linear vector space is defined by is defined by a set of elements x, y, z, etc. called vectors, and a field of numbers A, B, C called scalars with certain properties, with the following properties. And so linear vector space is defined by a set of elements having scalars and vectors. Now we are going to discuss which all properties are obeyed throughout this linear vector space. And the first one is space is closed. Space is closed under vector addition. Under vector addition. That is, if we add let x vector and y be two elements in a linear vector space, and if we add this x vector and y, we get another vector z. So z would be an element of z would also be an element in the linear vector space. And second one is commutativity. That is x plus y. Let x and y be the two elements in a linear vector space. If we add x, y and y plus x, this would give the same result. Then third one is associativity. That is, if we add x vector, let x, y and z be three numbers in the three elements in the linear vector space. If we add y and z together, then add x, it would be equal to x vector plus y vector plus z vector, and it would be again equal to x vector plus y vector plus z vector. Then the fourth property is that the existence of a null vector. Existence of a null vector. That is, if x vector is an element in the linear vector space, then there would be a null vector that would again, if added to x vector, we get the same vector again. And this thing is closed under scalar multiplication. Fifth property is closed under the linear vector space is closed under scalar multiplication. That is, if let C be a scalar and a linear vector space, and if we multiply scalar with a vector, then we get another element y, where y would be also the element of the linear vector space. Then the sixth property, multiplication by a scalar is associative. Multiplication by a scalar is associative. That is, if we are having a number a and multiplying with vector plus y vector, this would be equal to a into x vector plus a into y vector. So we can say that multiplication by a scalar is associated. Again, in the multiplication, if you are multiplying two elements, we are having the seventh property. Sorry, the eighth property. C into x vector would be equal to x vector into C. Then the ninth property is AB into x vector, where A and B are two scalars. Then A into B into x vector would give A of B into x vector, and would be again equal to B vector into A of x vector. Then there exists an multiplicative inverse. Multiplicative inverse. That is, we have some element x and it is having an inverse 1 by x that would give the identity value. Then another property is that there exists a multiplicative identity. That is multiplicative identity. That is that if we have a vector x vector and we multiply it by some element, we would again get the same vector. So the value we multiply to the linear vector space to get the same element is known as the multiplicative inverse of the element. Sorry, multiplicative identity of the element. Now, a linear vector space is said to be unitary if the inner product is defined in it. So, any 3D vector, any three-dimensional vector can be represented using this three elements in a linear vector space. Suppose we have a scalars called a1, a2, a3, and we have unit vectors e1 cap, e2 cap, e3 cap. Then any vector in three dimension, any three-dimensional vector can be represented as a1 into e1 cap plus a2 into e2 cap plus a3 into e3 cap, where a1, a2, a3 are scalars and e1, e2, e3 are unit vectors. So this is all about linear vector space. In the further video, we are going to discuss about the sudden inner product Hilbert space, and coming topic would be in the next video. Thank you.